Good? Limit as x approaches infinity from the square root of x squared plus 4x plus 1 minus x. Yes, please, Eddie.
Are you allowed to divide throughout a square root?
In an equation, I'm allowed to divide, unless I divide by the variable, which is not allowed. But this is not an equation.
So you could,
I can only multiply by 1. That's the only thing I can do. But the specific type of 1. What?
I mean, the conjugate, yeah.
Correct. That's the only thing I can do, multiply by 1. But let's discuss this. Where does this go? Bless you. Where does it go? Good. Where does this go? Good. So this is case number 3 that of indeterminate. Infinity minus infinity. We had 2 cases before. We had case number 1. We had case number 2. We have to look at 4 more this semester. There are 7 total. However, the only chance I have is the conjugate. There is nothing else. I can only multiply by 1. This is 1. But how does this 1 look like?
Square root of x squared plus 4x plus 1 plus x.
Very good, thank you. I cannot square, I cannot divide, I cannot multiply anything. I cannot do anything but multiply by 1. Well, a wise type of 1, not just any 1. A particular 1 that clears the numerator of radicals. And underneath I'm going to factor out x squared as like we just did. 1 plus 4 over x plus 1 over x squared. And please give me the numerator when you're ready.
4x plus 1.
Very good. Indeed, it's 4x plus 1. I will factor out what in the numerator, please? It's the degree, which is good. So 4 plus 1 over x. Since this is the square root, x approaches infinity, and I have the square root of x squared, what can I replace this piece by? Good. Perfect. What is my next step? Factor out for this, and now I can drop the limit operator. Where does the top go? Where does the denominator go? Careful. 2. This one and this one, correct? 4 over 2. So this is 2, which means y, since this is infinity, y equals 2 is the horizontal asymptote. At infinity. This is not a rational function. It's a combo. So I don't know what happens at negative infinity. Actually, I do know. It's not going to be 2. Okay, very good. Next question, please. I'm hoping you're going to finish all the homework from chapter 2 between now and Thursday, so you're prepared. If you want to start a little early, I don't want to forget to say that, Eddie, forgive me. If you want to start it early, you're more than welcome to start early. If you think you're going to need more time, I'm here. Okay? My previous class ends at 2, so I'm here. I cannot offer you time afterwards because there is another class. I mean, we could go next door, but I'd rather start early if you need to, if you need more time. Okay, anything else here? Eddie, sorry, forgive me.
You can do the same thing for B, right? Because B is a constant, you should divide out.
You're talking about this?
Yeah.
Let's do it. Limit Sx approaches infinity, 1 minus e to the x over 1 plus 2 e to the x. Where does the top go? Yeah, infinity or negative infinity, I don't care. The denominator? Good. Good. So what do we do? We are pulling out what? To the x. Good. What is left? Good. Where does the top go? Where does the denominator go? So this is negative 1 over 2. Y equals negative 1/2. Horizontal asymptote at infinity. I also wanted to draw your attention with my previous class, which is pre-calc class. I didn't mention it because I thought it was clear, but everything has to be lined up. See the equal symbol, see the fraction line, in between, fraction line, in between equal symbol. I don't want to see stuff all over the place. The equal symbol here, the fraction line here, another equal symbol here or here, and 4 over 2. Please, everything has to be lined up. And there is a reason for this. It's not just me making a case. Okay, please, everything has to be lined up. Please make sure you have everything in a row. Okay, next question, please. Number 11. Very good. In number 11, we have limit Sx approaches 1 from 1 minus 3x divided by 2 equals negative 1. Good. First of all, I don't trust this, and you shouldn't. You should verify first whether this is correct. Is this correct? Yes, it's correct. So then, for sure, I will find an epsilon greater than 0 such that it will correspond a delta. There exists a delta such that every time I pick x minus, which is 1, less than, very good, this will always imply
so 1 minus 3 over x, so minus negative 1 plus 1.
excellent, less than,
Epsilon.
that's it, awesome. Great job, thank you. We start from here, the first part of the proof. What do you think I'm going to do inside the absolute value? Remember, we cannot remove anything, we cannot factor anything, we cannot put anything inside, we cannot take anything outside. There are only specific steps and only specific rules that apply here. But inside, I will have to do what? Correct. And always remember, I'm not teaching you how to cheat, but I'm teaching you what to expect and what we are after. After I finish with this, completely simplified, what should I get? This is what I'm after. From here, I do whatever is allowed or possible to get this. Good. So I have 1 minus 3x plus 2. Then what?
Factor out 3.
So we have negative 3x plus 3 divided by 2 in absolute value less than epsilon. Good. Next step, factor out what? Good. Not out of the absolute value, of course. Inside the absolute value, we can factor out negative 3. Good. What is left in parentheses? Right. So I'm on the right track. This is what I expect. I already got something close to that. Now I can apply the properties of the absolute value. And I have to write this step. Then I have to eliminate those absolute values on negative 3 and 2. The absolute value of negative 3 gives us a good. And there is a final step right now in which x minus 1, as expected, right here, is alone on the left-hand side.
2/3.
So we multiplied everything, both sides, by 2/3. What does this mean? You don't have to say anything. You don't have to guess. I have the absolute value of x minus 1 on the left-hand side. I have less than. What could this be? And in step number 2, show that delta equals to epsilon over 3 works by reversing the steps from above. You do not have to reverse them. You just have to write. Anything else?
Can I see a step?
Yes,
Please,
please.
like move the.
Yes, of course. Is this okay?
Mm.
Is there anything else from this test that you would like to go back? Yes, please.
I have a question about that.
Yes.
Do you have to write out that whole
You mean this?
definition? No, like,
This?
The precise definition of the
yeah.
Yes. But not in the
You
symbols.
can't just start at absolute value of,
No, you have to write the definition, but not using the symbols if you don't want to. You have to say that this limit equals -1 is equivalent to saying that for every epsilon positive, you will find a delta, corresponding delta positive, such that every time you pick x close to 1, the distance between the function value and -1 will be less than epsilon. You must write that step, with or without symbols, up to you. Yes, please.
For the first step, when you're doing 1 minus 3x plus 2 over 2, how did you?
This one?
Yes, ma'am.
The least common denominator is 2. This is 1 over 1, so I have to multiply it by 2. The initial denominator was 1. Now it became 2. It means that I multiplied the denominator by 2. I have to multiply the top by 2.
Gotcha.
Better? Anything else? Is there anything else from this test that you would like to see? Yes?
Number 2, that's when we do the h goes to 0. Right?
Yes. So for number 2, let's just start it. We don't have to finish it. But here you have f prime of x. You have to write the limit. You have to write h approaches 0. And you have to write 4x plus 4h plus 1 over x plus h plus 3 minus 4x plus 1 over x plus 3 divided by h. And you know what has to happen, right? You will find the least common denominator at the top. You will find the adjustments. You know that all terms without h must go away. And so that will enable h to go away in the denominator by factoring out an h. Anything else? Yes, please, Eddie.
Isn't there the other way you showed us where it's H can equal A.
We're asked to use the definition of the function of the derivative here. But when we are asked to find f prime of A, you can have two options. But when we're asked to find f prime of X, we only have one option. Anything else?
So is it, that's gonna be in this format?
In this format, yes. Is this okay? Is this problem okay? Yes? Is there anything else from here? Yes. Anything else?
For
Yes?
number 3,
Yes?
can we set up
Yes,
the
of course. Will you be able to finish this one up with no problems? I mean, we had the same thing on 2 quizzes except this, right? Is everyone okay with this? Okay. So we're looking at a piecewise defined function, which is a square root of 1 minus x for x less than negative 1. And it's x squared minus 1 for negative 1, for x between negative 1 and 2. And it's x plus 2 for x greater than or equal to 2. Here we are asked to graph this function, find its domain and range, see if it's continuous from the left, from the right, if it has a removable discontinuity, whatever we find out about the function. So then, first, I change this into negative infinity to negative 1 with a parenthesis. Acceptable?
Mhm.
Then I change this inside into negative 1 to 2 parentheses in both cases. And then I change this into a bracket, which is 2 to infinity. Then I have to identify the domain. And after that, I start the table. So can anyone look at those intervals and give us the domain of the function? Chris?
Negative infinity.
Careful.
Not including negative 1.
Excluding negative 1, correct. Eddie? Is that what you wanted to say? Excellent. So please be careful. One option will be to do this or this. You either write a bar like this, double, triple, whatever, meaning undefined at negative 1, or you put parentheses and it's still undefined. Good. The other number that has to be in the table, or the other numbers I should say, 0 always, and 2 is a key x value. I know that between negative infinity and negative 1, I will have to use the square root of 1 minus x. Between negative 1 and 2, I will have to use x squared minus 1, and then I will have to use x plus 2. Under 2, can anyone dictate the symbols under 2? This going which direction?
Close parenthesis facing 0.
I can't. It's a parenthesis facing this way. I can't change the direction of the parenthesis. And I can't change the direction of the bracket. It's facing that way. I only copy what I see. I don't change anything. See 2 parentheses here? Left parenthesis facing left, right parenthesis facing right. Left parenthesis left facing left, right bracket facing right. I can't change anything. I just copy what I see. Is that okay, everyone? Okay, perfect. So now I'll say here negative 3. When I plug in negative 3, I get 4 underneath, and the square root of 4 is 2. Now this is ugly because it will be the square root of 2. I'll figure it out. When I plug in negative 1 on this side, I get 0. Careful, these numbers are inside parentheses. Or, like this, if you use this system, which I will use later, you can write negative 2, the square root of 2 and 0. Then 0 is -1. I should also insert a 1 because it's 0. And then when I plug in 2, 4 minus 1, 3, inside parentheses. Then on this side I plug in 2, and inside the bracket I have 4, and I plug in 3, and I get 5. From left to right, can anyone dictate the first ordered pair?
Take granted.
1, 2, 3, 1, 2. The next ordered pair is kind of hard because this is 1.4, -1, 1.4, and it's an open point. I know how to graph the square root, so it's not a straight line. Please do not graph it as a straight line. So that's the first piece, and it's done. The next piece starts at -1, 0, which is, I'm sorry, I just realized I didn't go far enough. It goes to -1. I stopped at -2 by mistake. I'm sorry. It's right here. Okay. So the other piece on the right-hand side, it starts at -1, 0, which is here, still open. They don't touch. At 0 is -1. At 1 is 0. And at 2 is 3, but it's an open point. This is an open point. And this is quadratic. I have to graph it as a quadratic function. Now the last piece is 2, 4, which is a full point, and 3, 5, which is also a full point. And this is f of x. Please do not overlap these pieces. They don't overlap. The blue piece stops here, the red piece is right in the middle, and the black piece starts at that point and to the right. And now we're asked to identify whether this function is discontinuous. And you will say discontinuous or not continuous, where? At x equals -1. It's undefined, basically, right? If it's undefined, it cannot be continuous. And also at x equals 2, which is a jump. Discontinuity. Here, -1, it's undefined, and a 2 is a jump. Does this function have a removable discontinuity? Remember what a removable discontinuity is. This is a removable discontinuity. A hole, but both sides go to the same value. This is not removable. This is removable. Both sides go to the same value, but just the function value is not there. Does this function have a removable?
Yeah.
No. No removable discontinuity. Very good. Anything else?
I have a question.
Yes.
For the first one that we graphed,
Yes.
Oh, did you just go? So the square root of 2 would be 1.4, and we would put that
Yeah.
on the graph.
Yeah, you're right. I went too low. You're right.
Okay, I just wanted to make sure.
No, it should have been a little bit higher. You're right. Sorry.
No.
Yes, it should be between 1 and 2, not closer to 1, right?
Right.
Roughly between 1 and 2. Thank you. Yes, of course. Thank you very much. Very good. Other questions here? Yes, please, Chris.
How many sharks do you go through in a semester?
It's a very good question, and I have to tell you that just in the last maybe 2 or 3 semesters, I have to purchase at least 2 or 3 boxes per semester. They used to last, I probably they put half in it. So they would used to last at least a full semester, not anymore. It's just, or they dry out very quickly, or they just cut corners. Yeah.
So the Domain would be negative.
Yes, the domain is a negative, what we see here, negative infinity to negative 1, union negative 1 to infinity. So domain, negative infinity, negative 1, union negative 1 to infinity. And the range will be from negative 1 to infinity.
Right.
Very good. Anything else? Is there anything else from this test?
I think the only thing left is number 12.
Right. Okay. So in number 12, what I wanted you to present, here is the function fails to be differentiable if it's not continuous, if it has a cos for a corner, or if it has a vertical tangent. So in details, I would write that the function is differentiable if it has a unique tangent. And that's why cos, corner, and discontinuity don't have the same tangent. But in the case of the vertical tangent, the derivative is a limit, right? The derivative equals the limit of the difference quotient. So the limit cannot be infinity or negative infinity. And that's what happens in a vertical tangent situation. Now, let me ask you one question. Is there any particular type of problem that you say, well, I feel like I would like to see another one? Any type of problem from the past lectures, anything that you worked on, anything that you would like to see again? Is there anything else? Anything? Anything? Of course, if you have questions, I recommend again, even if you don't want to start early, I would recommend you come in early on Thursday if you have questions, if you come across something that you need help with. Anything else?
Can we do number 4?
Number?
Number 4?
Number 4.
I think it's like the last one we did do.
Oh.
I don't think we did number 9 either.
Okay, so what would you like me to do? Number 4?
Number 4.
Okay, so in number 4, remember that table that summarizes all the information. This, in my opinion, is the best, being organized and reading all this information and putting it in the table. And then you can easily come up with a graph. So first of all, I see f of 0 equals 0. That's done. Then I see limits at positive and negative infinity are 0, which is y equals 0 is a horizontal asymptote. So that's done. Then I see something happens at 5. And they say the limit from the right of 5 is infinity. And the limit from the left of 5 is negative infinity, which makes me conclude that this is a vertical asymptote. And that is done. Then I see at negative 3, the function from the left has a limit of 2, and the function from the right has a limit of 0. So that is done. And now the only thing is that the limit from either side of 2 is infinity. So I'm going to insert 2 in here. So x equals 2 is a vertical asymptote, x equals 5 is a vertical asymptote, and I'm going to come up with my suggestion. So this is y equals 0. This is x equals 2, the vertical asymptote, 3, 4, 5. X equals 5. I put both asymptotes in there. And now the graph. Ready? So also at -3, 1, 2. So on the right hand side is 0, and on the left hand side is 2. So now the graph from 0 to 2, fine. That's one option, not the only option. And then -3, 0 is this point. It has to pass through 0, 0, and it goes to infinity on the left hand side of 2. No problem. In between here, I have from positive infinity to negative infinity. No problem. And on the right hand side, I have from positive infinity to 0. This is my suggestion. You can come up with many other functions. Anything else? Okay, let's also look at number 9. And we have f of x, which is x minus 1 over x squared minus 3x plus 2. Any questions on the previous problem? Any questions on the previous problem? Yes?
Between x equals 2 and x equals 5, when you're going across the x-axis, are you hitting any particular point, or is it
No,
just...
just anywhere. You can do whatever you want. You can even do this if you want to.
Okay,
You can do whatever you want. As long as the given conditions are fulfilled.
gotcha. All right.
Okay, so here, of course, I will look at this function and factor it completely and immediately. And before I simplify, I have to state restrictions. And the restrictions will be x not equal. Exactly. X not equal 1 and x not equal 2. But since x equals 1, x minus 1 disappears, this must be a whole. And since x minus 2 stays, this must be a vertical asymptote. However, it's not sufficient. I have to find the limit as x approaches 1 from the left of 1 over x minus 2. I have to find the limit as x approaches 1 from the right of 1 over x minus 2. I have to find the limit as x approaches 2 from the left of 1 over x minus 2. And the limit as x approaches 2 from the right of 1 over x minus 2. So I already established that x equals 2 must be a vertical asymptote. I already established that x equals 1 is a whole, but I still have to determine the limits left and right for both in both cases. Let's start with the easy one, which is 1 from the left and 1 from the right. What is the answer?
-1.
Perfect. And what is the answer?
-1.
Good. So what type of discontinuity is 1 comma -1? Removable. It's this situation. Left and right limits are the same. It's just that the function value is not there. Very good. So now this situation, I know it's a vertical asymptote, so I know the answer must be infinity, but I don't know which sign. So here, 2 from the left, what is the sign? 2 from the left means 1.9. And the sign is? Negative, I agree. 2 from the right means 2.1, and the sign is? Positive. So one final thing here I need to determine is the limit as x approaches infinity. Since a rational function, it's going to be the same with negative infinity, of 1 over x minus 2. And the answer is clear. 0. Y equals 0, horizontal asymptote. Any questions?
How did you determine there was negative infinity?
because it's a vertical, the sign you mean?
Yeah.
2 from the left is 1.9. 1.9 minus 2 is a negative number.
Gotcha.
2 from the right will be 2.1 minus 2 will be positive. And the top is positive. Anything else? Anything else?
Is there anything like specifically we need to show so we don't get points taken off?
You mean from here?
Just like the quiz overall, like you
The-
want us,
the-
like how we should show work.
Well, I'll be here, so if you have any doubts, you can always ask.
Okay.
That's one thing. Secondly, if you do what I show in class, that's more than enough. You can use a graphing calculator, but if you just punch in the numbers and come up with 3, I can give credit for that. You can check that. But if you're in doubt, since I'm gonna be here, you ask any question. Is there anything else you would like to ask? Yes, hold on, yes.
How did you find out it was removable?
Because the limit from the left and the limit from the right are the same,
Okay.
but not equal to the function value because the function is not defined there.
Okay.
So both limits are the same. So remember, removable means the limit of f of x as x approaches a from the left and as x approaches a from the right are equal, but they are just simply not equal to f of a.
Gotcha.
That's the only problem. Otherwise, the function would be continuous there. Yes, no, I'm sorry.
So two things, or well, one thing, for like times like number 11 for the precise definition of the
Yes.
limit.
Yes?
Did you forget something in there? Did you get the whole thing wrong?
No.
Was all?
No, I always get partial credit. No. Anything else?
So
What was the second question? I think you had 2 questions.
I was just gonna say like remember to keep the limit until then.
Yes, please. Yes, I will. I cannot give full credit if you do that because it makes no sense. You cannot drop the limit operator of, let's say, x plus h over x plus h squared and then all of a sudden come up with 5. It's the limit that is 5. It's not the function that is 5 equals 5. You understand? So if I, on the previous case, let me look right myself here. Let me just go back to any limit that we looked at. See, if I have this limit, and at some point in time, let's say, of course I can find it when I need it. Yes, right here. So if I write it this equals this without the limit, that will be incorrect. Because the limit of this does not equal this. The limit of this quantity is the limit of this quantity. And if I drop the limit here, and I simplify, and I get 1, that will be incorrect. So the limit operator disappears only at the very end, when I'm ready to plug in 0 for t. Good, other questions? Yes.
So the horizontal asymptote is 0.
Yes.
And the vertical is 2.
Yes.
So
See how I find out? He was looking at your cell phone. I didn't want to say anything, but I was getting ready to say it at the end of the class. Yeah. But I don't have to say it anymore.
so as far as like writing the -1 and -1, that's to let you know that it's a removable.
No, that's a very good question. The vertical asymptote is guaranteed to be there, but I'm also asking you to determine the limits.
Oh, okay.
Right. So it's not
Including
just
the pretend.
yes, including the limits.
Okay.
Let me explain why. Because in chapter 4, we are going to graph these functions, and I want all this information to be already ready, to be already on your mind. So now I don't want to come up with, oh, by the way, when we find the vertical asymptote, I will also have to find the limit left and right. Now you know that we have to. Good. Anything else?
Yeah, we know 1 is a whole because of the 1 minus 1.
1 is a whole because the factor goes away. The factor goes away, and that does not change the restriction. The restriction is still there. So you cannot state restrictions after you simplify. If you do, that will be a mistake.
Okay.
So you have to state restrictions before you simplify, and then you say, okay, this factor goes away. The function is still undefined there, but it's not going to be a vertical asymptote, because the factor doesn't stay at the end. But this one stays. X minus 2 stays, so then x equals 2 is a vertical asymptote.
Okay, gotcha.
Good. Okay, I only have 7 minutes left, so I was thinking that if I had like 15 or so, I would have started chapter 3, which is not going to be on this test. So let's find something else for a couple of minutes to work on then. So I'm not going to start chapter 3. That was on my mind to start chapter 3. So let's find something else, like 1 or 2 problems to work on. Something, yes. Ready? Go ahead.
Is there any tips on how or when you should know to use the like when to sandwich the function?
Yes. Yes. Very good question. So basically, is when you see a sine and cosine.
That's the when it's trigonometry.
Yeah, because that's the function that is bounded.
Okay.
These are the 2 functions that you already can start by saying between -1 and 1, and then I multiply all 3 sides.
So the inner function has to be oscillating for that to make sense.
Yes, yes, because that really helps you determine the left and right function, the top and bottom. The other option now would be a function that is not given to you, but you are given the top and the bottom. We had a problem like that, if you remember. Yeah, so that's a very good question, actually. Yeah, when you have no way of simplifying, no way of rationalizing, no way of, and you see a sign, that should trigger your memory, yes.
Are we gonna have to do this on the test? For the
No,
epsilon
the
goes
graph,
from the
no, I'm
side
not
to
gonna ask you to do that. I'm sure you understood the idea there.
Yeah.
I am going to look at, however, at the WebAssign. So I'm going to look at also some problems from there. The problems I think in WebAssign are they appear to be a little bit easier than the ones we selected in class, maybe. So I'm gonna look at that too. Anything else? So everything will really be common sense. I mean, I'm not going to invent anything. I'm not going to come up with anything that you have not seen. So if you diligently work on the problems we did in class throughout the last 3 weeks, this is the 4th week of classes already. Wow. Finish your WebAssign homework, you should have 0 difficulties. None whatsoever. I'm not testing endurance, so I'm trying not to have a problem there that you need 3 pages to work on. No, I'm testing understanding and basics. So, however, I would come in early on Thursday if you have questions, if you want to work on anything.